All right. I know there's a delay, so we usually give it a second. We'll kick it off usually 10 seconds after. So, ladies and gentlemen, welcome to the Global Online Meetup for this month. And we're going to be talking to the team from NeuVector and what is new with NeuVector 5.2. I have two very, very special guests. I have Glen Kosaka and I have Tracy Walker. Gentlemen, both thank you first for coming and happy to have you guys here. We'll kick it off with you, Glen. Quick introduction.
Yeah, hi everyone. I'm Glen Kosaka. I'm head of product security, looking after the NeuVector and other security products at SUSE.
All right, and Tracy?
Hi, everyone. Tracy Walker. I'm a senior security engineer with SUSE, specializing in NeuVector.
Awesome. So I will turn it over to you guys. I will interrupt. There's going to be questions coming through on the chat channel here. I'll interrupt the talk and ask those questions as we go. If we do not get to your questions at the end, then feel free to go to the Rancher user Slack at slack.rancher.io, and there's a channel in there for NeuVector. Pop your questions in there. We'll get back to them later if we don't get them today. But without further delay, Glen, over to you, sir.
Thank you, Robert, and thank you, Tracy, for joining me today. So we're very excited because we haven't done a global meetup for security or NeuVector for some time. So we're going to get caught up on all things new with NeuVector today. So what we plan to do today is I'm going to do NeuVector by SUSE in 5 minutes. So some of you who are joining probably are not as familiar with NeuVector as some of you veterans, but I don't want to go completely into all of the NeuVector product line and features. We'll do that later. So I'll just do a quick 5-minute overview, and then I'm going to hit what's new in the 5.2 release, which came out just last month. So some exciting new features there. And then I'm going to turn it over to Tracy to show us some of those exciting new features, such as the Sigstore cosign integration for admission controls, Harbor, scanner adapter, and other great things. And then I've asked Tracy to give a little bit fuller or broader view of NeuVector. So for those of you not as familiar with NeuVector, he can talk about, and drill down into the full lifecycle container security, and if time allows, show some of those features. And then I'll come back and talk about where we're headed in the future with NeuVector. And then we'll have Q&A. We can have Q&A during the session today, but we'll hopefully have some time at the end to have a dedicated Q&A session. Okay, so a high level picture here. Basically, let's talk about all the bad things that can happen in container security and Kubernetes deployments. And we like to talk about the life cycle of an application, which starts in development and then goes into build, and the pipeline is stored in registries and tested and then is deployed into production. So it's really in any of these stages where security issues or exploits can happen. Vulnerabilities can be either introduced or discovered anywhere in the pipeline. New vulnerabilities can be published for things that passed and are sitting in your production registry, and tomorrow can have a critical log4j type of vulnerability disclosed, as well as pods running in production. So it's critical to check for vulnerabilities and new CVEs throughout the entire pipeline. Misconfiguration issues, we've seen many of those, just simple things with consoles being left open, or permissions and service account permissions not being locked down. And that can open up all of your infrastructure, whether it's your Kubernetes API server, kubelet, your host, registries, for potential attackers to get in and compromise. Now, it's not necessarily an exploit, but in the background, we have to deal with the fact that in this modern container cloud native world, security can't slow down or break the pipeline. So any type of manual configuration or manual steps, lack of integration, is going to slow down the continuous release process. And the business and the developers aren't going to be happy about that. So everything has to be as automated as possible. And then in the production environment, we have not just the traditional container, which is an application attack surface, but we have the tools, the Kubernetes API server, whether you're using Docker, Istio, other tools that you're using that could be attack surfaces as well. And of course, depending on the application and what interfaces or connection protocols it's exposing and using, all of your network attacks, exploits, cross-site scripting, SQL injection, all of those types of things are still possible. So those things need to be taken care of as well in a containerized environment. So there's a lot to be aware of. Fortunately, we can automate a lot of this, and we have many layers of security that are offered with NeuVector. So this is a good way of looking at it, kind of just bifurcating it into supply chain and runtime. And so in the supply chain, we have CVE scanning, CIS benchmarks, and other custom benchmarks that you may choose to implement through NeuVector. Admission controls are really the last defense into the production environment, or the last gate to enforce some kind of policy about what gets into the production environment. And that includes image signature verification. There's a lot of talk these days about supply chain security and SBOMs. Signing of images and verifying signatures is another critical aspect of supply chain security. On the runtime side, we have zero trust segmentation. Really, any zero trust controls mean that you're going to define what's allowed in the environment rather than what's trying to be blocked. It's really a new model of security, which fits very well with how Kubernetes is declarative, because you can declare what's allowed while you're deploying your applications. And that alleviates you from having to chase vulnerabilities or exploits or signatures or other types of patterns that are always kind of looking in the rearview mirror. But at the same time, we have to have some traditional, I would say, old security model controls in there as well, because they're useful. So I would put things like vulnerability scanning, network threat detection based on known network attack patterns, and WAF, looking at web application firewall attacks and having rules to check for those types of attacks. Those are all more traditional security that we can use to complement our zero trust approach. And then, of course, we can look into the data and the packets and the connections and make sure there's no data being leaked out of our infrastructure. So that's another good control to have. Another way to look at it in the pipeline view is on the vulnerability and compliance management. It starts with scanning images or during the build process very early in the cycle. The Harbor adapter is one example of that, and Tracy will talk about that today. Continuously scanning the registries, because as I mentioned, vulnerabilities can occur at any point. Running CIS benchmarks and any other custom audits are going to make sure that either inadvertently or by some malicious activity, some type of configuration of your Kubernetes deployment, the pods, the hosts, the nodes, any of those things has not been opened up and is less secure than you want it. Compliance reports are always critical for many of you to achieve, either PCI, GDPR, NIST compliance. So those are all things that can be generated. And then finally, it's important to continuously scan everything running in the production environment, container hosts, platforms, because those things can change. Make sure they don't drift or that there's not new exploits that we have to worry about. And then on the runtime side, we've talked about admission controls. NeuVector has a container firewall, so it's very unique in doing layer 7 deep packet inspection, where you can do protocol verification, segmentation based on application protocols, ingress and egress controls based on DNS host names, as well as DLP and WAF protections. In addition to that, each container or pod that's running is monitored for process and file activity. And so if there's any unauthorized processes that start or file access that shouldn't be allowed, those can be alerted as well as blocked. And then I mentioned the importance of automation. The whole architecture is really very cloud native. It's declarative. So as early as the developers creating their deployment manifest for your application, you can also create a security policy manifest, a YAML file that declares what kind of behavior is allowed in production, network connections, protocols, process file activity, admission control, other types of rules as well. So that's how this can be built into modern GitOps processes, where security processes and rules are codified into code, checked in if they're going to change, if you're going to add your new network connection for your application, you simply check out that security manifest, you add that allowed connection to your manifest for your application, you go through the test cycle, check it back in, declare it, apply it, and then that becomes the security policy of record that can always be reviewed, updated, and secured. So that's NeuVector at a high level and in a nutshell. Now, what we've done recently, and I thought I'd go back to, a year because some of you haven't seen what we've released earlier as well. So in November of last year, we had a pretty major release, and that included centralized multi-cluster scanning. Really, that enables you to have a primary cluster which manages a bunch of remote Kubernetes clusters. And if you are able to scan your registry at the primary level, all of the scan results are going to get propagated down to the remote clusters. And that enables you to enforce things like admission control rules that rely on scanning for CVEs or other compliance violations.
So real quickly, Glenn, I apologize for asking. We had a really important question about the 1.5 release. Is the .NET scans just for the latest version of .NET, or does it support some of the legacy like 4X versions of .NET that only runs on Windows?
Yeah, I mean, I believe we support, so basically the way we support any type of scanning is we subscribe to either that vendor's or that open source project's feeds, as well as, of course, NVD, MITRE, et cetera, public PVE feeds. So to the extent that any of the older versions are in the .NET feed, then yeah, we will scan for those as well.
Okay, great. Thank you, sir.
And on that point, on the right side, you can see that's mainly adding breadth and additional scan sources, supporting different platforms like Cilium, CNIs, OpenShift, new versions, et cetera. The next thing I wanted to highlight is network protection for complex network routing use cases. And we won't have time to dive into that in complete detail. It's probably kind of confusing. What the heck is that? But the reason I bring it up is, as I mentioned, NeuVector can look at every packet and all of the deep packet information, the packet information in there. So we can look at things like host names, we can look for DNS resolutions, and in complex use cases such as a host names getting resolved outside of the cluster to two different IP addresses, or even the same IP address, but two different host names, and there needs to be different network rules for those. NeuVector can handle some of those more complex cases. We focused on being able to very granularly tune NeuVector for performance and sizing, especially in large cluster deployments like 500 nodes to 1,000 nodes within a single cluster, and edge deployments where you're very resource constrained. There's a very limited CPU or memory or even network bandwidth footprint that's available. So depending on the specific security features that you find most important in your environment, you can turn those on, turn others off so that they're not going to consume as much resources for your environment. Auto scanning scanner pods, auto scaling, that should say auto scaling scanner pods. Just like any public cloud auto scaling capability, when it gets busy, if you're scanning 100,000 images in a registry, we're going to need, maybe 50 scanner pods to each be running in parallel. And then it can scale back down when it's done with that project. Okay, so now for the most recent release last month, very exciting features in there. Sigstore cosign signature verification. Tracy's going to talk about that. Harbor adapter, I talked about that. Really continuing to enhance the security of NeuVector itself. So how you access the API can now be done through tokens in addition to username, password, and then really locking down each of the different container types within NeuVector has different permission levels based upon what that specific container requires. In the past, they all had the same. So now we're moving toward a more best practice, least privileged permission deployments. For government and other regulated environments, if you need to have special login pages and logos and banner headers and footers that kind of warn people about top secret type of access, or have them accept special terms, now that can be done in NeuVector as well. Public cloud marketplace, supporting subscribing to NeuVector support through SUSE, through public cloud marketplaces like AWS. The free version of NeuVector has always been available on Docker Hub and GitHub, and through the AWS marketplace. But now if you have an AWS account and you want to spend your funds through AWS for SUSE NeuVector, then you can do that today. And then for subscribing customers, there's a number of assets and services that have been newly made available for subscription customers, such as advanced performance tuning and sizing, CVE database lookup service, and we plan to add to other services as well. All right, so with that, I am going to turn it over to Tracy to show us some of these new exciting things.
All right, well, as Tracy's bringing it up, we had a quick question. How many clusters can NeuVector handle as that administrator cluster and scanning below them?
That's a great question. We don't have, we don't limit it in terms of the number, physical limit. But what we do tell our customers, anywhere, when you're getting into the 100+ clusters, you probably need to work with the SUSE support team to help to tune the environment and the architecture so it's optimized to be able to support that many. It's really more of the practical things you might run into when you're in hundreds of clusters, where if you're going to look at a GUI and there's 500 in a list, it's going to be harder to navigate without some filtering and tools.
Sure.
So those are all things we plan to add over time. I know that, like, for example, some edge deployments have 1,000 clusters or 2,000 clusters. And for those, we really recommend other edge type of solutions for managing policy, for monitoring, NeuVector, that our edge team, SUSE's edge team, brings to edge deployments of NeuVector.
Awesome. Tracy, the floor is yours.
Yeah, thank you. And just to add on to that, you can see here where when we talk about the federation, we've got a primary and we've got a managed cluster here. So this is only showing 2.
Mhm.
Let's say you had 30 or 50, you would have a whole list here, and you would also have this drop-down list. So you'd be able to navigate from your primary to these federated. And then the rules that you can federate to all of those clusters. You can federate admission control rules, global network rules. So we always kind of recommend these are kind of like the, thou shalt not do these things. So that's gives you kind of more of the global rules. And then you can still have the granularity on those clusters for individual rules or policies that you have for specific clusters. We often see users federate, like, say, production clusters, and then they may also have another federation primary for upstream clusters that are, QA, dev, that kind of thing. So you can have multiple federation masters, and they won't talk to each other, but you can, further segment that way if desired.
Awesome.
All right, so let's talk a little bit about some of the new features. The first one I would like to kind of show off is our Harbor plugin. So I'm going to actually log into a Harbor environment. And the first thing I'm going to point you to is, so Harbor, under the administration interrogation services, allows you to add different scanners. So you can have multiple scanners. And you can see here, we're going to just show this particular scanner as we've got this one already set up. So it's going to hit this endpoint for NeuVector, and this is how you're going to set up the scanner. So a little background in how this works. So we're actually running an additional container in the cluster. It's actually a connector, and I'd like to show a very, very simple diagram of kind of what that looks like. So Harbor, we're deploying, so NeuVector deploys as containers inside the cluster, right? So it's containerized application, Kubernetes native. So we have a controller container. We also have scanner containers, as Glenn was mentioning earlier. These can now scale up and down automatically. So you could run one statically for, on the fly requests. But then when the controller is going to scan like a registry or going to be scanning lots of different images, it'll automatically scale this scanner. So the way the Harbor plugin works is we're running another container called the Harbor connector. And so what this connector is doing is it's kind of acting almost like the manager does. So like when you go through the NeuVector UI and you say scan this registry, it queues up, gets a list of all the images in the registry based on the filters, sends that to the controller. Controller tells the scanners, hey, we're going to start scanning now. You might have to scale up, that kind of thing. Scanners return the results to the controller. The controller returns it to the manager, etc. Well, in this case, it's going to return those results to the Harbor connector. Now, the reason we do this is because normally normal scanning plugins, like in your Jenkins plugins or Circle CI or stuff like that, doing pipeline scans, only scanning one image, right? So they're just basically saying, scan this image. So we don't need this kind of go-between queuing mechanism, right? But in this case, with Harbor, we maybe say, well, scan all of my images, scan 1,000 images. And so what we do is the connector is basically the piece that is going to queue up all the scans and the scan results. So Harbor will make the call over the connector. I need you to scan 1,000 images. The connector will let the controller know, hey, I got a lot of scans to run. And so the process kind of runs exactly the same on the back end. When the results are returned, the Harbor connector is actually queuing these results because currently there is a 60 seconds. So Harbor will send the request and then it's going to check back in 60 seconds. And so meanwhile, all of this work is happening, results are queuing up. And then after 60 seconds, you're going to start getting results back with the next time it checks in, assuming all the scans have been completed and things like that. And then once Harbor is receiving those results, then you'll be able to see those results. So in Harbor, you would set up a scanner. So we've already got the scanner set up. And then when you go to your project, so we'll go to this test images project. And here, if I click on scanner, you can see that we have selected that same NeuVector scanner. So this is the scanner that is defaulting for this project. And if I go to my repositories and say, oh, let's pick we'll just choose this red hat right here. So I already have some results. If I were to select this and select the scan button, you can see here it's going to queue up. So this is where you'll see the scanning. So all of that activity is happening on the backside where it's actually going to do the scanning. So you can have this set as your default for multiple projects within Harbor. And also that 60-second default will be, or probably will be, configurable in the future. That was one of the things that came up in testing is, can we configure that to make it shorter? Or if we know it's going to be longer scans, maybe we don't want to have Harbor pinging every 60 seconds. But that's essentially, so that should be configurable in the future. It doesn't, one other question that did come up was, does this mean that it'll scan, I can only get results for a single scan every 60 seconds? And the answer is no. You're going to get all the results of everything that was done over the last 60 seconds. It's just kind of minimizing a lot of the back and forth traffic, so Harbor doesn't have to constantly ping the connector to get those results. So yeah, that took, we'll see here. We'll get, there we go. So now we got results. If I want to click here on the, go back to our, well, maybe this is showing my unfamiliarity with, here we go. We'll click on the image. So we're getting image results here. And then here you see the results from the scan. So that just came back here. So we're showing the fixed version. You may notice that the CVS score is not showing up. We currently return both the version 2 and version 3 score. We have raised this issue. So we've done a lot of troubleshooting. Currently it's a bug. Not quite sure if it's a bug in NeuVector or Harbor, but we've had a couple of other scanners saying they're seeing the same issue. So we're not quite sure if the definition in the API documentation is exactly correct. We know we're returning this information, but Harbor is still just not showing it. So small bug there. So if you're not seeing the score, we're returning that information. You can find that information, but it's just not appearing in Harbor right now. But you are getting lots of other information there. You are getting what version it's fixed in, things like that. If you click on the CVE, we're also returning the source of that CVE information. So very similar to what you would experience if you were in NeuVector, you're going to get that data as well. And now you can use NeuVector as an additional scanner. Quick security tip, and this is just good security. You really shouldn't trust any scanner. We recommend that you use multiple scanners. The reason, because scanners can have different ways of checking for vulnerabilities. And often what we've found in our experience is when users are comparing one scanner to another, they sometimes will get different results. In fact, most of the time they will get different results. Sometimes it's false positives, false negatives. So our recommendation for just good security practices is you should use multiple scanners and maybe compare the results there, because that'll show you the deltas and maybe things to look into. And you know, often I hear someone say, well, I've compared them and this is the one I trust the most. I wouldn't trust any scanner. It's not saying that our scanner is not good or that any other scanner is not good. It's just the way that scanning is for signature-based vulnerabilities, right? And if you're doing signature checking, you should always have a red flag in your mind that signatures are never complete. CVE databases are never complete. There may be a CVE release today that is not on this list. That's a 0 day, right? So it's just this constant battle of trying to keep up with your CVE remediation and things like that. And that's why we recommend the zero trust segmentation. So that is the Harbor plugin. So that is new in 5.2. Super excited about that. Another nice feature that has come available is Sigstore verification. So let's go to my assets. So if you are familiar with previous versions of NeuVector, you will notice under assets, we now have a Sigstore verifier. And this is super cool. So I'll add a couple of things here. Hopefully you don't have to watch me type too much. You can see that we support both private and public Sigstore root of trust. So we're just going to do, I'm just going to use the public root of trust here. And to do this, I'm going to need, let's grab a public, here we go. So I'm going to just name this, I'm going to name it public root of trust. That's all I need. This is Tracy's. Actually, let's just say Sigstore. There we go. And because it's public, everything's already kind of built in. We already know where the public Sigstore is. So we'll just add that. Then the next step is then you have to add a verifier. And so in this case, we're going to call this one TW key pair. And then, and this is okay to show because I have a public key. So I will add that public key. And it's okay to show this and have it recorded, right? That's the way keys work. So we'll add that key. All right, now I've got a public key, or I've got the verifier, the Sigstore root, as well as a verifier there added to that. So how do I use this now? I've just added the public key. Well, I have a container that has been, that I have added. And so if I go here to this key, and you notice I've already added this registry to save us a little bit of time. So, and if I click on this particular container, you're seeing our scan results. So the layered scan results that we get from our registry. Notice that we don't have anything that says anything about any keys or anything. Well, let's rescan this particular image. So I'm going to start to scan on this registry. This should be pretty fast. You can see now we're scanning. And now it's finished. So we just completed that scan. And now if I click on that scan, where is, dun, dun, dun. Did I miss a step? I don't think so. I've got the Sigstore verifier, got my public key. I know my image is signed, and I was expecting to see that show up here on the side. And I'm wondering if I have I don't see that it has scanned that particular image again. That's why I'm kind of like, So that image, I'm going to just try it one more time. I am in the prime. All right, scan is finished. I just don't feel like I'm getting a fresh scan result because it's 9:34 here, and I'm not seeing the update there. So I may be hitting a little bug in just my environment here, which makes me very uncomfortable because that's what I want to show, is that we have that showing up now. And let me do this one quick. I can do this actually. Let's try this. I'm going to delete the registry. I may have found a bug setting up the demo, creating it, deleting it, re-adding it, things like that. So let's call this, and I can do this super fast. Saves us some typing. No password needed. I want to scan my layers, submit that. Here it is. No images there. Now I know that we'll get the latest scan.
This always happens when you're doing a live demo.
And there it is. And now you're seeing, previously we were looking for this, but now you can see we've got this public root of trust, and we actually can verify that yes, we have found that key. It matches the one that I have added to NeuVector. So now we have that key. Oh, fine, fantastic. Now we actually see the key, and now we can use that key. And to not spend a great deal of time on this, but now we can create a admission control rule. So in the admission control, I can now go hit the I, drop me down to images, and you'll see here now we can check to see if an image is signed, or we can use the verifier to say it has to be this signature that image has to be signed on. So we can create that image store. It must contain this right here, which would be, and I'll just add it, but we can, since add that public trust of root / with the key pair there. You'll notice that we do give you some examples, so take advantage of those, but we'll add that. So the verifier must contain this one. And if it has multiple keys, we support multiple keys, must contain all of my keys. Or if I want to create a deny rule and say, well, if it doesn't have this key, deny the deployment. And another cool thing about our admission control is if I wanted to limit this to a particular namespace, I could also do that. And so my namespace here is Vader W1. And so now I can just check the signatures just for that namespace, for any images that I'm deploying to that namespace. And another new feature, notice that it has this mode here to use the global mode or monitor or protect. Now, what is that? If so, again, new in this version of NeuVector, we now can have individual modes for individual admission control rules. I'll just add this one here and we'll keep talking about that. So previously, the mode for the monitor and the protect was globally. So you didn't have this row here showing monitor and protect. Everything was in monitor or everything is in protect, right? Protect is the enforcement mode, which would block the image from being scheduled in the cluster. So an enforceable admission control. And one of the frequent user requests that we were getting from our users was, hey, can we just fix this so I can select this individually? So now you can have, well, for example, if I move everything to monitor, all of the rules that were set to the global rules are now showing in monitor, and now we're enforcing those rules. If I move back to my monitor here, they will change back, but notice some of them didn't. And that's because individual rules can now have individual enforcement. So that means that now for that admission controller, anytime we try to deploy, we were going to also we're going to check that image. We're going to check that, make sure that sign it matches. And now we can do sign checking on your images.
So there's a couple questions coming in. One of them here is from an individual. The trace route, quote unquote, command still works even when I block CMP traffic to the network. I think that's a specific use case. Post your question in the Rancher user Slack. The channel is NeuVector-security. I think it's a little more deeper than we can take on this call. But another great question, Tracy. Does admission control conflict with Rancher RBAC settings? And I think that there might be a little bit of confusion there. We can clear that up. Explain what admission control is doing to ruin what we're going to talk about later in the month about admission control and RBAC settings for Rancher.
Yeah, so the admission control is really just checking. That's just checking whether or not the image is allowed to enter. So very similar to the deprecated pod security policies before they became pod security admission, PSAs now in Kubernetes. So same kind of thing. It's the admission controller at the edge of your cluster. And it's the analogy I always use is like, if it's club Kubernetes, you got a guard at the front door checking everybody's ID to make sure that they're old enough to drink, right? Admission controller is just the same. It's going to check these rules for the images before you allow those images to run. Now, the pod security policies that have been created, did some things, but what we did is we've created our own validating admission controller. And well, I won't even show you the drop down. Let's show you the rules. So we now support all of these rules, 31. These are all pre-built. One of our partner projects, Kuborden, if you wanted to get really deep into admission control, Kuborden does a fantastic job with like custom. You can write any kind of admission control rule that you want. These are pre-built. We do support some custom criteria, so you can do some customizations, but the difference between, like, say, the NeuVector and the Kuborden, you can automate or make those individual and very unique, write your own custom rules and validating as well as modifying admission control rules. These are just validating. So we're going to validate these things. If we have a problem with one of them, or, there's permission problems or something like that, we're not going to modify and fix that on the fly. Modifying admission controller can do that. And then we can have that debate about, is that the right place to do that or not, right? Everybody's got different opinions. Every environment is different. So not good or bad. So these are the admission control policies. You'll notice that there are some here that are familiar with CVEs, whether the image has CVEs, are they fixable CVEs, things like that. So this is all because we're able to do the registry scans. When we scan the registries, we can use those results for our admission control rules and allow whether those images are going to be allowed to run in the environment. And again, you can use this in a monitor mode where you can just collect all the data. So if you don't want to, if you don't want the risk of accidentally blocking something, start out in the monitor mode and collect all the data for all the kind of violations. We even include some things like we have this pod security policy best practice, which includes, let's show that, which would be a great place to start. There's some basic ones that we recommend. PSP best practice is really good because it includes containers that would run as privilege, run as root, sharing namespaces. It includes those previously deprecated PSP policies. Well, we've kind of kept those around because they're good policies to have. And we've put them all into one. And like I said, we can put that in a monitor mode, add that. And now we're going to check and let you know if you've got any of those issues. So hopefully that was good there. On the ICMP, that is a very specific case. I will tell you, and I'll even explain a little bit of the runtime side, but the not blocking certain types of network traffic that are used for like health checks and things like that, and within Kubernetes, we're careful about blocking certain things like that. So it could be a case of that. We might have to dig deeper on in the Rancher Slack channel, and we can talk to you about that there.
There's one more deep one if you're ready for it, or we can hold it to the end.
Sure.
Right. I love these deep questions though, because these are great. This is coming from LinkedIn, and individuals that reached out asked if they haven't found any information on running NeuVector in a VMware Tanzu environment, TKG vSphere with Tanzu, if there's limitations with that. And I think that's a great question to respond because if I remember correctly, it just needs except for ARM and ARM support, but NeuVector just needs a CNCF certified cluster. Is that correct?
Yes. Yeah. So NeuVector can run in Rancher, OpenShift, Tanzu, all the cloud environments, GKE, EKS, AKS, IKS, EIO. I think it's on the Farmer too. Yeah, the whole alphabet. We support all of it.
So I guess they're looking for a little more documentation on that. That's a great question. We can take that back to our docs team and see if that's something that they can address. But I just wanted to make sure we do the call out there. It just needs to be a CNCF certified distribution of Kubernetes, and NeuVector should work. And I know there is a limitation currently that they're working on around ARM if it hasn't been fixed yet. I'm excited for that one because I have a lot of ARM devices that I want to put NeuVector on to see how well they handle.
Yes. Yeah. I'm excited about that as well. We are working with the engineers at ARM. Our engineers are working with their engineers. I'm helping even as well. So yeah, that's coming very, very soon. Yeah, true. There isn't, like, you've got the Kubernetes Rancher, Red Hat, OpenShift, etc. We don't have one for Tanzu. I believe you can, Glenn, tell me if I'm wrong, but I think you can just continue to use the Kubernetes or the Helm chart approach.
Yeah,
and
the
just
Helm
deploy
chart,
it like any other application or workload.
Yeah, yeah. I mean, we didn't see any special settings. The only one is a normally you have to pay attention to is what is the container runtime. So I'm not aware in the latest VMware Tanzu if they're using Containerd or still with Docker, but that is a setting in the Helm chart to specify the container runtime. That's the main thing that needs to change in the deployment. But other than that, it's a pretty straightforward Kubernetes deployment.
Awesome. Hopefully that answers your question. Very
cool. Let's see. There's a lot you can see here in the release notes. You can go to the release notes in the documentation, and you can see there's a lot of things that have been updated and added and fixed and things like that. We're definitely not going to cover all of these kind of things. I think that the big one, with the monitor protect on the individual admission control is big. The adding the Sigstore verification and things like that is pretty big. And since we have just a little bit of time, I do want to kind of cover and kind of compare the security layers, because too often, and we kind of talked about this internally, but too often security vendors are all about talking about all their features and things like that. And they tend to sell features versus selling good security, right? I need layers of security. I know none of my layers is perfect. I'm wanting multiple layers so that I have defense in depth, so that layers are supporting each other. Like, if you get past this one, I can stop you here. And if you get past that one, I can stop you here, right? That kind of thing. And so a lot of the layers that NeuVector add, when we add layers, well, you can kind of put them into two groups. I can anyway. Threat signature layers are all based on matching threat signatures. So this is where your CVE scanning comes into place, where you're looking for CVEs. Our DLP capabilities, so even though that's a runtime capability, it's still based on regex. So we're looking for credit card numbers and social security numbers, or any kind of information that you want to make sure if it was attempting to leave, we would see it in the network traffic and we could stop it before it egresses the environment. Our network attack detection, so we can detect live network attacks. That is signature based, though. That means we have to have a signature. We have a ton of signatures. Here's all the different signatures, network attacks that we can detect live. When we detect these things live, we trigger an automatic packet capture of the actual attack. So that's one of the capabilities that you get with NeuVector when you're using it. We inspect the network traffic, not just the network routes, right? All the vendors talk about how visibility is on their buzzword bingo card, how they give you visibility of network traffic. Well, they're kind of showing you the routes, the layer 3, layer 4 information. They might be looking at IP tables within Kubernetes, things like that. NeuVector doesn't do that. NeuVector actually inspects the network traffic off of the VNIC. We don't use sidecars or anything like that. So our network attack detection uses signatures and matches those signatures against what it's seeing in the actual network traffic. Our WAF capabilities, malware, ransomware, any of these things, it's all signature based, right? A signature based means it's allow all by default, right? Think of this as a no-fly list when you're going to the airport. If your name is on the list, you may not get to fly for whatever reason, right? But that we're allowing all by default because it's using as the signature base. Zero trust is deny all by default, meaning you have to be allowed and authenticated to enter the secure environment. So just like flying through the airport, it's not an analogy. It is zero trust. When you go to the airport, there's a secure perimeter. You enter that perimeter by going through the security gates. You have to be authorized to go there, meaning you have to have a ticket that says you're going to board a plane. And then you have to be authenticated. They didn't want to check your ID. So you're checked, you're authenticated, you're authorized to go to fly on the plane, and then they scan you anyway. They scan everybody. They scan the pilots, they scan the stewardesses, the flight attendants, et cetera, right? Everybody gets scanned. It's deny all by default. So you don't even get to go in unless you are authorized and authenticated. And of course, it's also continuously monitored. So that's what zero trust is. So the NeuVector zero trust is allow policies, right? We are learning your network behavior, your processes. We're building allow rules for that. As Glenn was mentioning, we can export that as code. Also gives you the ability to apply countermeasures, meaning you can take action. You can quarantine the container. You can do packet capture on that container. You can put it into protect mode and start blocking anything. So that is the little demo that I'm going to do for you, is that zero trust, because this is the thing that makes NeuVector so different than everything else. I have a container here that's running in this cluster, and that container is exposed to the open internet on this little, oh, I'm not in the right place. Let me do this, get to the right. We'll change all this after this video. So the IP address of my website is here now. I'll plug this here. And there's my app. So I've got this app. It's running on the open internet. I can create new orders and things like that. If I come back to NeuVector, we already have some rules for this. We've got some network rules. We've also got some process rules. So what I'm going to do is I'm just going to delete these so we can just start from scratch. So I'm going to delete these network rules as well. We'll save that. Awesome. So now if I come back to that container and I look at my process profile rules, I don't see any there, and I don't see any network rules. So let's move this to our discover mode. So discover basic means I need to see the processes. I need to see the network connections. We'll submit that. Move this to our discover mode. This is the default mode when you start, actually default zero drift mode, meaning we'll explain that later, but there's a different mode for that. Discover mode just means I'm going to learn the rules and the processes. So we'll come back up here to this. We're just going to refresh the website. I'll create a new order just for Robert, being such a great host. All right, so I'm just generating a little bit of HTTP traffic. And what do we see here? Well, we see Java is running on this container, and we are starting to see some HTTP traffic because I'm doing this really fast. To prove or kind of show how we can learn things on the fly, let's shell into that container. All right. So if I do an ls, who am I? Let's do a wget to Amazon.com. Excellent. I'm just running some commands in this container. And as I run these commands, you'll notice, see the bash and the ls and the wget. We're learning that as I do that. We're building these rules. And notice that they're allow rules. That means that these things are allowed. Network rules. I should be seeing some. There we go. DNS traffic, because I was hitting Amazon.com. Yes, we build rules based on DNS as well. We can see that. And you can see also that I'm bashed into that container. So we're learning all the network traffic. We're learning all the processes. Now let's move this to a protect mode. We're going to enforce our zero trust. You have the option of monitoring it, just collecting the data, not blocking anything, or blocking. And before I continue, I'm going to delete the bash and the ls in the wget because that's not my normal behavior. That's what I was just doing, screwing around in that command line interface, right? So I won't worry about the network rules. Let's just focus on the processes, right? I'm still in the container. You can deploy NeuVector during an attack. You can use NeuVector as a rapid response security tool. Regardless of what other tools you might be using, NeuVector is open source. You can deploy it with a Helm chart in about 5 minutes, and it's up and running, and then you can immediately take control of a cluster, even if it's under attack. Why? Well, I'm in this container. You could consider this an attack. I can't do an LS. I can't do a DU. How about a remove recursive force star.star? See, operation not permitted. Who am I? I thought I was root. If I try to exit this container and get back into the container, I can't get back in. That is what zero trust is doing, right? So another way we could test this is, let's see, got to get my command again. We could attack this container. In this case, I can run this attack in our protect mode. And you see it's not really doing anything here. But this is an actual attack. I'm running a reverse shell or code injection, if you will. If I go to my security risks, notification security events, you'll see right here, see this Apache struts remote code execution. So, and you can also see the bash. So see all the things that I was just doing that were being denied here. But this one in particular, this, if I show the packet, that's the actual attack. And as I scroll down here, you can see there's the IP addresses. That's the attack. I was trying to run netcat to run this attack, right? So that is the packet capture. And this is threat detection, signature-based threat detection. This is not zero trust. This is one of those layers that we have that says, well, if we can detect the threat, we can block it just based on that fact alone, right? And stop it right there. You notice that there's not really any other things coming through as far as bash or any other commands. There's nothing else running here. Well, what if I was not in protect mode and we didn't block this? What if this was a 0 day? Has anyone ever shown you what a 0 day would look like? All right, well, we'll show you what a 0 day will look like. So I'm going to go back to my policy groups. This is where all my pod groups are. I'm going to move this now to a monitor mode. We always recommend monitor mode to start out with because that way you can test, you can make sure your workloads are not seeing any other activity, and you won't block anything. So it's not dangerous, no performance impacts. The discover mode and the monitor mode, there are no performance impacts whatsoever. So now we're in this monitor mode. This thing has timed out. I'm going to run that command again. But before I do, I'm going to set up a listener because this is the real deal. And on this listener, we're going to do a netcat. I'm going to do it on the 1337 port. And you see the -L, that's a listener. So
can you, I'm sorry to interrupt. Can you increase the font size just a little bit? So
I can.
Oh, thank you.
Yes, we'll increase that a little bit. So this is the listener. I'm going to queue up some commands. They're not going to work until let's do an ls, a du, and a who am I. Those will trigger once that connection is made. And that connection wouldn't have been made in the protect mode because we were blocking this attack right out the gate. But now if I run this here in the monitor mode, we're not going to block it. So if I hit return here, immediately got an error on this side. So we see this HTTP says, so that means I did hit Tomcat. I was hitting that Apache web server that's running on that container. It didn't like it, but over here, I'm inside as root. Who am I? Root, ls, du, wget. Let's not do the wget because I want to keep my things working here. What is NeuVector saying about all of this mess? Well, let's go back to our notification security events. First thing you're going to notice is see all the things over here are alert, right? We're not blocking. In fact, the last thing we blocked up here was this bash I was trying. But you can see when we did this before, we blocked here based on the threat and nothing else happened, right? No commands were executed, anything. But now when you see the alerts, Yes, that is my IP address here in Denver. That will change right after this, right after this webinar. Yes, we do detect it still in the monitor mode, but I'm going to ask you to ignore this. Pretend this is a 0-day. Pretend we don't have a signature, because that is the reason why signature-based security is not perfect, right? You need lots of layers for signature-based security because you're looking for the signature. You're literally lining up the world saying, I've got to check every name because I'm allow all by default. Well, when you're using zero trust, we see the netcat, the ls, the du, the shell, we see the tunnel commands, right? That is what a 0-day actually looks like. It's going to look like a bunch of commands, new network connections that you haven't seen before, maybe going to different countries that you don't belong to, that kind of thing. That's what a 0-day would look for. You can't scan for a 0-day. There's no CVE definition for it. You're not going to be able to block a 0-day unless you know your application behavior, unless you're doing zero trust and you're authorizing and authenticating all the processes of network traffic. So this is what makes NeuVector different. We're the only product that does this. Zero trust, automatically learned, easy to implement, and as Glenn mentioned, exportable as security as code. Because everything you just saw me do in about 5 minutes, I can export into a YAML file. And I should have had BB edit up before that. And there it is. I have a YAML file that has all of my security policies, my file protection that we didn't even talk about, the process protection, the network connection, as well as my WAF settings, my DLP settings, etc. So this is extremely valuable. Now I have portable zero trust I can apply to other clusters. This is the core of what makes NeuVector so effective at adding security layers that are network centric, not using eBPF, not at the kernel, not limited to layer 3, layer 4 network information. We see all the network traffic that comes off the VNIC. You don't need agents. You're not changing any code. You're not doing eBPF. Just deploy via Helm, and you can have this up and running very, very quickly.
So real quick with that, an individual could do, who knows that security as code is bound to a particular application for a 0-day, right? Because it's not universal across all of them. So an individual could do this in dev and, effectively try to attack it, know their application and start learning about it in a safer environment, and then move that up into a production environment.
Mm-hmm.
And then from there, add on some more security, with that.
Yeah, so the rules will apply. You'll notice that we've got this nv.struts.vader TW1 struts, right?
Mm-hmm.
So we're concatenating the service name as well as the namespace that it's in. So if you're running the same image, but you're running it in different namespaces, we will treat that as different rule sets. So you want to be consistent with your namespace across those dev environments or things like that. And actually, I'll just show the slide that we use for our training, or some of our training, kind of explaining exactly what you were just talking about, Robert. Yes, you can do this in any upstream environment, learn the rules, export the rules. The only correction I would say is no environment is safe. You always have to validate your rules, right? Every environment should be considered to be compromised. You just have to treat it that way. That's just your best security practice. So yes, this is your first stage. You just want to get the CRD rules and get into monitor mode, test things out, make sure that you're not seeing violations. You can even compare environments, which is another very handy way to use the tool. We've seen users export the CRD from prod and compare it to the CRD that was in their pen test environment to see, well, what is actually different? What connections are happening over here for this namespace that aren't happening over here? If they look exactly the same, that's an awesome thing. You've got really consistent behavior across all your environments. But if you're seeing behavior in prod, doesn't always mean it's bad, but there's definitely something that is different. And then you want to know why it's different. Is that okay? It just brings up a lot of those kind of questions. And yes, eventually you're probably going to be in a mix of monitor and protect modes. You can be full protect, you can be full monitor, but as long as you're in one of those two modes, you've got the zero trust. Discover mode does not implement the zero trust. It's establishing the baseline. So you want to move out of Discover, within a day or a week or something like that in a fairly short time period.
Awesome. Now we are a little past the top of the hour. I think. Is there anything else that Tracy you want to demo? Not seeing any more questions come through.
No, nothing here.
Okay.
Great. So
Glen's back.
Why don't I wrap up with a couple things that I wanted to share. Thanks, Tracy, for the great demo. Let's see. Am I showing anything?
Not yet. Let me do that for you. There you go.
Oh, so a couple things. So we often get asked, okay, why should I subscribe to SUSE's support services for NeuVector? So, obviously there's the standard support questions that can be asked, break fix, bug investigations, things like that. But beyond that, it's really helping you with configuring all those security rules that Tracy talked about, how to integrate it, automate it, use the REST API, use CRDs. There's a lot of questions about how to use CRDs in a GitOps workflow. So the team can help with that. A lot of questions about, is this CVE in the database yet? What version of the database is it in? Why am I seeing it here, but not in another tool I'm using? So triage of all of that is critical. Helping to optimize runtime rules, configuration, and then tuning of the NeuVector architecture and features to make sure that it matches your environment. So there's a number of assets and services that exist today, as well as we'll be adding to those that are part of a subscription. I think the bottom line is if you have a CSO, CISO, CIO, you probably care about your data and your business assets. And if there's a breach or a hack, you don't want to have the answer be, hey, we were trying to run free and do our best to protect our sensitive data. That won't be a good excuse. So please consider that. And the last thing I wanted to cover was the roadmap. So we've covered all of these things on the latest side. Coming next, we're looking at more advanced denial of service protections and analysis of what kind of rules are getting hit. So you can take a look at those and maybe feed those into an AI engine for analysis. Egress hostname report, that's a real cool one. I like egress control. It's one of the great features of NeuVector. But the hostname report is really, imagine you got a bunch of developers deploying all these apps. You're the security team and you're in the staging environment and you're seeing all these external connections to 50 or 100 IP addresses, and you have no idea where they're going and what they're for. Often those are FQDNs, host names that are being resolved into those IP addresses. And if you just could match up those IP addresses with the host names, you could say, oh yeah, that's our internal database service. That's an approved external service. Whoa, what is this going out? It looks like open source update service. No, we don't need that. Or here's a backdoor that was introduced into this open source. So the ability to match egress IPs that we're seeing with the actual resolved or where it was resolved from hostname will give the security teams a much better and more efficient way to see what should be allowed as far as egress reporting. Adding Microsoft and Google Marketplace billing, more integration with the Rancher Manager UI. There's a new plugin extension architecture for Rancher Manager, and so there'll be a NeuVector UI extension for Rancher Manager, NIST reporting, and then as we talked about earlier, ARM and IBM Linux S390 support is coming at the end of the year. So we're very excited about that, making great progress on that. And then in the future, past end of this year, more reporting for multi-cluster vulnerability events, those types of things, centralized policy management, more integration with GitOps workflows, statistics I talked about, and then enhanced API security. So you can use NeuVector today for some form of API security, but it's very manual. You have to manually define allowed rules and URLs that can be allowed to go to API services. But something that is a little more automated would help many of our customers. So that's where we're headed. Very exciting things. And of course, the information is forward-looking and subject to change, as you guys know. It's software, so sometimes roadmap items do move around.
Yep.
So with that, Robert, thank you for having us today. Tracy, thanks for the great demo.
Yep.
And we look forward to hearing from all of you.
Yes. So thank you, everybody. I posted a link where some of our next, I guess, live events will be coming. Tracy is going to be doing one about emission controls later in the month. I am very excited about that one. Anytime I can take a deeper dive with I'm going to be honest with everybody. I took a few notes because I wasn't fully aware of some of this stuff in 5.2. So I personally took notes on this one. So I learned a lot. But emission control, Tracy, you're going to come back. You're going to do another live show. That'll be hosted within Rancher Academy, not here on YouTube or LinkedIn or Twitter or wherever you watch this stream. So that'll be on the Rancher Academy. You can find out more at rancher.academy. Gentlemen, thank you very much. And we'll see everybody else in the community.
Thanks, everyone.
Thanks, everyone. Thanks, Robert.